Hello everybody, welcome back to another video. In today's video we're going to be covering algebra. Algebra is the foundation for calculus and it is so incredibly important to understand before moving on. Algebra will be everywhere in this series, so it's good to take a step back and really understand what it is we're trying to solve. So let's start with a very basic, everybody should have seen it at least once, or maybe you don't quite understand it, but that's why we're going to be going over it. So the first concept here are like terms. And what is a like term? Well, in algebra we have what are known as variables, and variables typically will take on x, y, or z, although you can use any letter as a variable, but these are very common ones. And the way that you can think of variables is they are blank boxes where we don't know what's inside. Or, I say blank, but they're not blank. There's something inside, but we don't know what they are. And oftentimes, when we have different variables, it means we have different items in these boxes. We don't know exactly what's in these boxes, and that's kind of the point of algebra, is to solve that mystery. So x, y, and z represent different unknowns that we are going to be using and solving for. So we can't take x and add it to y because we don't know what they are. They represent some unknown number, and whenever we combine them, especially like here, we don't know what it would become. But if we have 2x plus 3x, we know that both of these are the same unknown, so we can go ahead and combine these. And this might look a little confusing at first, but if we plug in a number here, let's say x is equal to 2, and we plug it in, then we have 2 times 2 plus 3 times 2, which is equal to 4 plus 6, or 10. And now if we go ahead and grab our 5x and plug this in, we see we also get 10. So combining like terms is 100% arithmetic correct from an arithmetic point of view. You are 100% allowed to combine x's because the way that multiplication works, it is 100% allowed. However, you can't combine x's and y's in the same way because that unknown is a different variable. So let's go ahead and look at another example now. I'm going to erase this example and we'll look at another one. So let's go ahead and take 3, and let's color code these now. 3y minus 2x plus 4y plus 6x. So here we have our different unknowns, x and y, and we're going to combine like terms. So 3y plus 4y are one set of like terms, then 6x minus 2x are another set of like terms. So we can take these and add them, and we can take these and add them. So 3 plus 4 is simply 7, so 7y, and then 6 minus 2 is simply 4, so 4x. And there is a standard way of placing which goes first. Typically I'll do x, y, z in that order, so I do 4x plus 7y just for elegance, but it doesn't really matter. And now let's go ahead and look at one more example. So in the same way that we can't add x and y, the same is true for x and x squared. So if we have 2x squared and we have 5x, and we can go ahead and put like a 1 here, since if we simply have 5x, it's actually 5x to the first. Understanding that can be kind of helpful in calculus. That's the only reason I bring it up. So because these numbers are different from each other, we can't add these two numbers together. However, if we add another number, for example, 3x squared, we can add those to like terms. So 2x squared plus 3x squared plus 5x to the first. Again, we can combine these like terms and we get 5x squared plus 5x to the first. So like terms are an incredibly easy and straightforward place to start when talking about math. They can be a little weird to get used to at first, but understanding like terms is essential to understanding algebra. So let's go ahead and move on now from like terms, and we'll cover our next subject here, which is the distributive property. So if we have 3 times 5, and we use parentheses here to indicate multiplication, this is simply 15, right? We just simply multiply the 3 and the 5 together. However, if we have 5 times 3 plus 2, we can't simply multiply 5 to one of these numbers. We have to multiply it to both of these numbers. So we have to multiply to the 3 and the 2. So this would be 15 plus 10, which is 25. And to show that, and to show why that's true, we can add our 3 and 2 together, so we get 5 times 5, which is also 25. This is one of those deeper intuitive things that you would study, especially like if you're doing a proof-based class, you might go through and study the associative, distributive, commutative rules. I won't dive too much into that right now. However, do know that these rules are very fundamental and can be proven if that is something that you want to go and look at. For now, we're just focusing on that they are true and some of the aspects of them. So let's go ahead and look at a couple more examples here. Let's go ahead and throw our variables in now as well. So we're going to do 2 times x plus 4, and again, we multiply that 2 to both the x and the 4. So here we get 2x plus 8. So we distribute the 2 to the x and the 4. Let's go ahead and look at, what if we have a negative and we multiply that to 5x minus 1. So again, we're just going to multiply term by term, and we get negative 2 times 5x minus 2 times negative 1. So negative 2 times 5x is negative 10x, and then negative 2 times negative 1 is positive 2. So we flip. If we have a negative times a negative, this is equal to a positive. Let's go ahead and look at a little bit more of a complicated example now, just because these are very basic as far as algebra goes. Most of the time you'd get much more complicated than this. So what if we have two terms that have addition in them, and we're multiplying these to each other? So again, we'd take our x and we'd multiply it first into the 3x and then into the negative 2, and then we'd take our 4 and we'd do the same. So here we have x times 3x and then plus x times negative 2, and this is your blue. And then we do the same, so 4 times 3x plus 4 times negative 2. And this would be your red arrows. So now we go ahead and simplify these by combining like terms. And we get 3x squared minus 2x plus 12x minus 8. And now we can combine like terms. So before we were just simplifying, now we're combining like terms. We see we only have two like terms, that's negative 2x and 12x. So we go ahead and combine those, and from our original problem here, our answer is 3x squared plus 10x minus 8. So let's go ahead and move on to the third idea now and this is just very basic algebra review. The third idea that we're going to be covering is factoring. Factoring is basically the inverse of the distributive property. So now instead of combining to get rid of parentheses, we're kind of taking out to create parentheses. It's a way of simplifying in some cases and can be pretty useful to be able to do. So let's go ahead and start with 6x plus 12. So we start with two numbers like this, or two terms, and we pull out what is in common. So what's the largest thing that we can take from both? In this case, it's 6. 6 goes into 6x, and it goes into 12. So it goes into, let's do blue. It goes into 6x and 12. And so we write what is in common for both of them on the outside, and then on the inside what's left. So 6x divided by 6 is just x, and then 12 divided by 6 is 2. So this is how we can factor. And factoring is a really important concept to be able to learn pretty early on. You'll use it quite a bit throughout algebra and calculus. And then if we want to show that our factoring capabilities are good, we would then just distribute this 6 to make sure we get our original terms back. And sure enough, 6 times 12 is 6x, and then 6 times 2 is 12. So let's go ahead and look at one more example. There we go. Ooh, that's gonna, sorry, I messed that up. Okay, now let's go ahead and look at one more example for factoring, and let's do 4x squared minus 2x. So from here, the largest thing we can divide from both of these is a 2x. And 4x squared divided by 2x is simply 2x. Again, we're going to put what's common on the outside and then what's left for each term. So 4x squared divided by 2x is 2x, and then negative 2x divided by 2x is negative 1. And there's many other factoring methods as well. These are just some basic ones just to get your feet wet if it's been a while since you've seen algebra, and to cover from the basics up. I always find it hard to cover from the basics up just because I have been mentally wrestling with these concepts for a long time. So it's hard to explain it from a fundamental viewpoint. But bear with me. So this is factoring in a nutshell. We're pulling out common terms to get a simplified expression. And then the last thing that we really look for in algebra is solving for those unknowns, those variables. I have plenty of other algebra videos on the channel. If you're interested in those, make sure to check them out. And let's go ahead and look at some of these examples. So how many solutions there are for your exponent depends on the order that your exponent is to. So for example, x is to the first order, so there's only one answer. X squared is to the second order, so there's two answers. And then same up and up. So if you have x to the ninth, let's use blue. If you have x to the ninth, then there's 9 possible solutions for x. Okay, now that we know that, let's go ahead and we're just going to look at some linear ones right now. Some linear problems, and we're just going to solve them for their variable. So let's start with 2x plus 6 equals 12. And when we're solving for x, the idea is to get x alone. We want to get everything to the other side. So first we're going to subtract 6 from both sides. And this will give us, let's do it below. 2x equals, here these cancel, and then 12 minus 6 is 6, so we get 2x equals 6. Then we go ahead and take any coefficients on the variable and we divide those out. So here we're going to divide by 2 from both sides, and we get x is equal to 3. And then let's go ahead and look at a slightly different problem. It's still the same concept, but now we're just going to be using some of the properties that we've shown. So let's take 3 times w minus 1. And let's say this is equal to 9. So for variables, again, we can use any letter we want to use as a variable. And oftentimes you'll see some textbooks change it up, especially because whenever you're doing physics, t is typically time, x is typically distance. So different variables have different meanings depending on what class you're taking. However, we're just using variables to represent some unknown here. There's no special hidden value to x or w as we're using it right now. So again, the first thing we're going to do is distribute this 3, and we get 3w minus 3 equals 9. Now we're going to start with our constant, and we're going to add it to both sides, so we're just flipping the sign to get it off of that side. So negative 3 plus 3 is 0, and then 9 plus 3 is 12. So we get 3w equals 12, and then we're going to divide out the 3 from both sides to get just our w, and here we see 12 divided by 3 is 4. So those are some very simple solutions to actually solve for variables, and it's an incredible skill to be able to develop now, especially if you don't know how to do these things. Make sure you brush up on some of your algebra skills before jumping into calculus. It's very algebra intensive. And thank you guys so much for watching. We'll be doing a couple more appendices videos, so a couple more algebra and a little bit of geometry, some lines, things like that. Stay tuned. Check out the playlist for more videos, and consider subscribing if you enjoyed the video. Thank you guys. Have a great day.